Welcome, and this is your last new lesson of the semester. The good news is it's not much more difficult than the last lesson. Problems are just slightly longer because we'll be learning how to multiply rational expressions and how to divide rational expressions. So what I'm showing you right now is your homework. So what I'm going to show you in the notes is I'm going to do problems 1, 3 in the evens. And then your assignment will then be to do problems 2 and then the odd problems. So that is what the expectation will be for you on your own with work shown. So this video is going to highlight problems 1, 3 in the evens on both papers. And you are welcome to pause, stop, rewind at any point. All right. So again, what I want to do is kind of divide the top 3 problems from the remaining because the top problems are monomials, meaning they are one term, and the bottom problems are polynomials, and we'll approach those differently. So for problem 1, reminder that when you multiply fractions, you multiply straight across. So if I multiply the numerators together, this yields 6a to the third b. And if I multiply the denominators together, I get a squared b to the fourth. Now this is a problem that looks like the previous homework. If I look at the number family, 6 reduces to 6. I have 3 a's on top. I have 2 a's on bottom, which yields an a on top. And then when I look at the b family, I have a b on top. I have 4 b's on bottom, leaving me with a b to the third. So 6a over b to the third would be my final answer. Let's look at problem 3. On problem 3, you are welcome to just multiply straight across and you're going to get big numbers. So what I'm going to choose is I am going to simplify first. You don't have to do this, but 18 over 10 reduces to 9 over 5. And 15 over 24 reduces to 5/8. And this just gives me smaller numbers to work with. So again, what do? I'm going to multiply the tops across, and that is going to give me 45x squared y to the third. I'm going to multiply the denominators together. 5 times 8 is 40, xy squared. And now this becomes a problem like we did in the previous topic. 45 over 40, both of those are divisible by 5, or you can use a calculator, and I get 9 over 8. I have 2 x's on top, 1 x on bottom. That yields an x on top. And I have 3 y's on top, 2 y's on bottom. So 9xy over 8 is a final answer. You should be able to do problem 2. Now when we go to problem 4, we are in the polynomial part of this. So what are your directions? We need to factor and cancel, just like we did in previous homework. But the difference is when I factor and I cancel, I just have 2 numerators and 2 denominators. So technically speaking, when you multiply across, you are welcome to FOIL that out, but I would not. I would look at this problem in 4 pieces. Hopefully visually that makes sense. You want to factor each one if it is factorable. So if I look at 2n minus 8, I can take out a GCF of 2. N minus 2 on the bottom just stays n plus 2. It does not have a GCF. It has 2 terms, and it is not a difference of squares or a sum or difference of cubes. But friends, just because you can multiply straight across, I can just write this as one fraction. So the 3n plus 6 also has a GCF. It has a GCF of 3. Then I'm going to write the n minus 4 on bottom. And now every factor up top can cancel with 1 on bottom. So the n minus 4s can cancel, An n plus 2 on top and an n plus 2 on bottom cancel because n minus 4 over n minus 4 is essentially 1. That's why we can say they cancel. N plus 2 over an n plus 2 is 1. That's why we can say they cancel. And what I have left is 2 times 3, final answer of 6. That is ultimately how we do all the problems. What's going to differ is your factoring strategies. All right, so on problem 6, again, I notice that this is a multiplication, and all we're going to do is we're going to factor cancel. So in the numerator, I have a GCF of 8. In the denominator, I have 3 terms. I have to figure out what 2 numbers multiply to 1 and at the same time add to negative 2. Well, that's going to be a negative 1 and a negative 1. Next, I'm just going to keep this as one fraction. X minus 1 does not factor. And in 2x plus 2, that is a GCF. I can take out a 2 and I'm left with an x plus 1. So now I can cancel. 1x plus 1 will cancel out an x plus 1. X minus 1 cancels out an x minus 1. So look at the numerator. In the top, I'm left with an 8. And in the bottom, I'm left with a 2 over x minus 1. But I'm not finished because you need to look at the numbers on the outside, and 8 over 2 can reduce. So final answer is 4 over x minus 1. Okay, what makes this problem difficult or why it makes it long is because you have 3 trinomials to work with. So I am going to expedite this video. There's just some work you're going to have to do on your own, and you can visit me in office hours if you're stuck. But when I look at the numerator, it has 3 terms. I have to find 2 numbers that multiply to 8 and at the same time add to 6. And those numbers are going to be 4 and 2. In the denominator, you need to AC that. Again, in the interest of time, you need to AC that on your own. We've been doing it since November, and I'm letting you know that you should be able to factor that into 2x and x, 4 and 1, both positive. You also need to AC the numerator of the second fraction. Again, I'm going to let you do that on your own, but what you end up with is 2x plus 1 times x minus 1. And this denominator, you need to find 2 numbers that multiply to 2, at the same time add to negative 3, and that's going to be x minus 2, x minus 1. So the hardest part, the longest part of this is the factoring. After you factor, the canceling is usually the part kids get. And how do I do it? I look at the first parentheses, and there's an x plus 4. I see 1 on bottom, I can cancel. I see an x plus 2. There is no other x plus 2s on the bottom. I can't cancel. 2x plus 1 has a match. X minus 1 and x minus 1 have a match. So your final answer is x plus 2 on top, x minus 2 on bottom. Number 10. On number 10, the numerator has 2 terms, so it's a difference of squares. So I get n plus 1 and minus 1. And then in the denominator, I have to find 2 numbers that multiply to give me 10 and at the exact same time give me 7. And that's going to be n minus 2, n minus 5. N squared minus 25 is also a difference of squares. So it factors into n plus 5, n minus 5. And then I need 2 numbers that multiply to give me 5 and at the same time add to give me 6. And those 2 numbers are going to be n plus 1, n plus 5. Now that your factoring is complete, you can start canceling. I have an n plus 1 and an n plus 1. I don't have an n minus 1 that stays. I have an n plus 5 and an n plus 5. I have an n minus 5 and an n minus 5. So my final answer is n minus 1 over n minus 2. Number 12. On number 12, if I look at the numerator, it has a GCF of 6x. the denominator. I need to find two numbers that multiply to -4 and at the same time add to -3. And those answers are going to be x minus 4 and x plus 1. I'm going to let you AC the numerator on your own or come to office hours if you're stuck. But that is going to factor into 2x plus 1 times x minus 4. And then there is GCF factoring in the denominator. I can take out a 4x squared, and I am left with a 2x plus 1. And now we start canceling. I have an x plus 1 on top and bottom, 2x plus 1 on top and bottom, x minus 4 on top of bottom. So what that leaves me with is a 6x over a 4x squared. But now you have to simplify it like it was one of these monomials. So 6 over 4 is going to reduce to 3 over 2, and an x on top and two x's on bottom give me 3 over 2x. So again, if you were successful with the new learning 2 weeks ago, this is really just more factoring and then you cancel. All right, so our last multiplication problem, x plus 7 does not factor. X to the third does not factor. This is a GCF factoring, so I can pull out an x. And then I need to find two numbers that multiply to -70, but at the same time add to -3. And that's going to be x minus 10 times x plus 7. So now I can cancel. The x plus 7's cancel, the x minus 10's cancel. I'm left with x over x to the third. And final answer, because this means x over x times x times x, I end up with 1 over x squared as a final answer. So now let's switch gears. Now we're going to switch gears to dividing. And here's the big idea. If I ask you to do 6 divided by 2, you know that that's 3. But remember that dividing by a number is the same as multiplying by a reciprocal. So if I change 6 divided by 2 into 6 times 1/2, that gives me 6 over 2, which is also 3. Dividing is the same as multiplying by a reciprocal. So the only thing the remaining problems are going to do is add one extra step. When I look at problem 1, the first thing I'm going to do is change it into a multiplication problem. You need to leave the first fraction alone. I'm going to change the divide into a multiplication, and then I'm going to take the reciprocal of the fraction that comes behind it. And now you have turned this division problem into a monomial problem that looks like the first problems we did at the beginning of this video. So what do? We multiply across. So this is going to yield 24a squared b when I multiply the numerators. When I multiply the denominators, I get 3a squared b to the third. And then I look for opportunities to simplify. 24 over 3 reduces to 8 over 1. A squared over a squared cancels. And if I have 1b over b to the third, I'm left with b squared. Number 2 is for your homework. Okay, number 3, notice that this is a division. So we are going to keep the first fraction all by itself. And now I am going to flip the fraction that comes after it. And now this is a problem just like we did earlier. I'm going to multiply the numerators together. So that is going to give me a 90 a, b, c squared d all over the denominator, which is going to give me a 15 a squared, b squared, c squared, d squared. And for my final answer, 90 over 15 reduces to what? 6 over 1. The a family, I'm left with an a on bottom. I'm left with a b on bottom. The c's cancel, and I'm left with a d on bottom. So folks, again, if you're noticing, these are monomials. So now we're going to do problems that are polynomials, and we are going to do them exactly like we finished 4, 6, 8, 10, 12, and 14, except we have to add an extra step by flipping the second fraction before we begin. So on problem 4, we notice that it is a division. So I'm going to look at this problem as 2n minus 4 over 2n times the flip or the reciprocal of the fraction that comes behind it. Now I factor cancel. I factor out a GCF of 2. The 2n doesn't factor. The n doesn't factor. And n squared minus 4 is a difference of 2 squares. So the n minus 2's cancel. And this yields a 2n in the numerator, a 2n in the denominator times n plus 2. And this is what's important. The 2's cancel and the n's cancel, but friends, the n plus 2 stays on bottom, and you can't have just something in the bottom without something in the top. Remember, 2 over 2 reduces to 1. N over n reduces to 1, so my final answer is 1 over n plus 2. Problem 6. Again, I would notice that I have a division problem. So I'm going to keep the first fraction the same. And I'm going to flip the second fraction. And now we factor. Difference of 2 squares. GCF. I can take out an m. 3m doesn't factor. And I have to find two numbers that multiply to negative 8 and at the same time add to 7. And that's going to be m minus 8, m plus 1. Now that we're finished with factoring, we cancel. So I see an m plus 1 on top and bottom, and m minus 1 on top and bottom. And that yields a 3m over m times m minus 8. But I can take this m and m, which are both monomials, and those can cancel, leaving me a final answer with 3 over m minus 8. Next, problem 8. Again, I notice that it's a division, so that means the first fraction stays itself. And then I'm going to multiply by the reciprocal. This problem isn't really too bad because there's only one thing I have to factor, and that is that trinomial. Two numbers that multiply to 6 and give me a negative 5 are x minus 2 and x minus 3. Then I can cancel out the x minus 3's, and that is going to yield 15 times x minus 2 over 5. Those can cancel, leaving me a final answer of 3. Oops, I have a typo there. 3 times x minus 2. All right, if I'm looking at problem 10, again, it's division. So that means the first expression, the first fraction, stays itself, but I'm going to multiply by the flip of the second. And now I proceed just like I did earlier. This numerator, we've already factored it in a previous problem. Two numbers that multiply to 1 but add to negative 2 are p minus 1 times p minus 1. P plus 1 does not factor. This p plus 1 does not factor. And p squared minus 1 is a difference of 2 squares. Once you have successfully factored, we're ready to cancel. This p minus 1 cancels out a p minus 1. There aren't any more p minus 1, so that stays. This p plus 1 only cancels out one p plus 1. This stays, so I get a final answer of p minus 1 over p plus 1. 2 more to go. Okay, on this problem, I see that it's division. So w squared minus 9 over 2w squared plus 13w minus 7 stays. And then this switches to a multiplication problem where I flip the second fraction. Okay, now, again, there is going to be some AC work that you're going to have to do in those denominators, and I'm going to let you do the AC work on your own. W squared minus 9 factors into W plus 3, W minus 3. AC, the denominator of 2W squared plus 13W minus 7. And you are going to end up with 2W minus 1 times W plus 7. 4W squared minus 1 is a difference of 2 squares. And again, I'm going to let you AC the denominator, and you're going to get 2W plus 1 and W plus 3. So now let's go canceling. The W plus 3 cancels. The W minus 3 sticks. 2W plus 1 cancels. 2W minus 1 cancels. So I am left with W minus 3 over W plus 7 as a final answer. And for our last question, I notice that it is divide, so the first expression stays the same. The second fraction flips. Let's go factoring. That has a GCF of 6. This has a GCF of 2. Two numbers that multiply to 2 but then add to give me 3 are 1 and 2. The x plus 1's cancel. The x minus 1's cancel. I'm left with 6 times 2 up top. So I have a final answer of 12 over x plus 2. So your homework is to complete the ones we didn't in this video. So problems 2, 5, 7, 9, 11, 13, and 15 on both worksheets. Have a good one.